So we're going to learn the classification with neural network. The content will be like this one. I will give you the overview about neural network and how the neural network works actually, and then we are going to learn about the backpropagation algorithm, the simple one, and let's see the summary. Basically, it is more general when we are doing the classification or we are doing the clustering, we are doing the regression. Yeah. Everything can be formulated in the mathematical form. So, for example, this is an example of the mathematical mapping of classification. You know that the classification is to predict the categorical class labels. And let's say I have the xi. Xi is the collection of attributes. I have x1, x2, x3, and until xn maybe. And I have y. Y is the target. So usually we call y is the target. And let's say this is the example of personal complex classification. I want to see, the personal complex website. So if you see the website, you want to classify whether the website it belongs to the ordinary person, or celebrity, your name. We want to check based on the words, the number of words that it contains in the website. So let's say the x1 is the number of word drama. X2 is the number of word scenario. X3 is the number of word child rearing. So child rearing is about the child related problems. So if it is more about the drama, let's say this one is 10, is 2, is 2. If it is related with the number of scenario, this data, then it is the website number 1, this is the website number 2, this is the website number 3. Okay, the number of the word scenario in this website is 13, the number of the word scenario is 3. Here there is no word about child rearing, there's 1 about child rearing, and there are 12 about child rearing. And okay, we can distinguish that this is 1. 1, the meaning is the celebrity. 0 means the ordinary person. So if we have like this data, it's easy to understand that all those data are numbers. You can make the mathematical formulation something like this one. The small x, it is the variable. It belongs to a set of data, which is the big X. So the small x means this is x1, x2, x3. It belongs to a set of features, and all the features are in the real number. So R means the real number. And n means we have n attributes. So it can be until xn. And y, small y, it belongs to the big Y. It means it is the set of target. The set of target, we have 2 labels, which is 0 and 1. 0 and 1. And in many paper or like the research paper, they will make this as a function x. Given x, can I know about y? So given the x, if I know this data, can I know y? Can I know whether the person is ordinary person or celebrity? So you can have many things with your data set later. So the neural network, it was started by psychologists and the neurobiologists to develop and test the computational analogs of neurons. So this definition, it is the definition, the general definition of neural network. It is a set of connected input or output units. Okay? We have the input or output units where its connection has a weight associated with it. During the learning phase, the network learns by adjusting the weight. So the key point is the weight. And we are going to able to predict the correct class levels of inputs. It is also referred to connectionist learning. Maybe some of the words about neural network, you can have the connectionist learning. And in the neural network, we have a set of connected neurons. We call it, the first is the input layer. And then we have hidden layer. This is the hidden layer, or it is in the middle layer. And we have the output layer. So this is the three layer that usually a neural network have. So in short, neural network is an algorithm inspired by the neurons in our brains, and it is designed to recognize the patterns in complex data. So our brain, it can recognize a very complex data. We can classify it easily. So based on that one, this neural network algorithm has been developed. So that's why the neural network consists of neurons, because this is the neuron. So we will see an example. We have this neuron. Okay. Let's suppose we have, this is x, this is 1, this is just a symbol plus. Okay. So this is a model that I can say that the input is the number of sugar. You know, if you cook something, there will be sugars. And let's say if I know the number of sugars or how many grams of sugars per serving, then I can know the output, which is the number of calories. Now, I need to have also the weight, and I need to have also the bias. In the linear unit, we can make it something like this. Y equal to weight multiplied by the x plus e. So this is basically a linear regression. Y equals to weight multiplied by x plus y. So it is the basic from the linear regression. And this expression can be seen with this node. How can we see this one? The y is the result, and it is the result from the x multiplied by the weight plus the bias multiplied by 1. Then we have the w multiplied by x plus b, because it is multiplied by 1, then it will show the result of y. Then we could estimate the calorie content of a cereal with 5 grams of sugar per serving. So let's say I have this model. So the sugar is the x, and then I have the weight is 2.5. And I have this b bias is the weight is 1, and the bias is 90. Then in the function calories, we can have the calories, we have 2.5 multiplied by the sugars, how many of sugars, plus 1 multiplied by 90. So if I know that the sugar content is 5 grams, so I can say this one is 5. Then 5 multiplied by 2.5 plus 90. 5 multiplied by 2.5, it is 12.5. 12.5 plus 90, then the result is 102.5. Okay, so this is the result with the linear unit based on this data. So this is the very simple example with the linear unit. How if we have this function? Then it will be more complex. So we need to make the definition. The W0 multiplied by the X0 plus the W1 multiplied by the X1 plus the W2 multiplied by the X2 plus bias multiplied by 1, and it will give you the result of y. Okay. Now, how if I have a dense layer like this one? So a dense layer with 2 linear units receiving 2 inputs and bias, and we have y0 and y1. Then we can distinguish y0 equals to x0 with this weight. Let's say this is the weight 0, 0. And then we have this one, x1. Let's say this is the weight 0, 1. And then we have this weight. Let's say this is weight 0, 2, or this is the bias. Okay. So we can have like weight 0, 0 multiplied by the x0 plus weight 0, 1 multiplied by the x1 plus the 1 multiplied by the bias. What about the y1? So the y1, let's say this is W10 and this is W11 and this is the bias. So we have W10 multiplied by the x0 plus W11 multiplied by the x1 plus the bias 2. 1 multiplied the bias 2. And so on. Okay, so we can make like this formula. So if we have more layers, then we can do it with the same things we had before. We can say that this is a single layer neural network because we only have the input layer and the output layer. That's the single layer neural network. We can have multi-layer neural network or multi-layer perceptron. We have the input layer, we have the output layer, and we have the hidden layer. And usually we call the MLP with only one hidden layer. If the layers are more than one, then this is the deep neural network. Sometimes we call it multi-layer neural network, but in many cases they call it deep neural network. So this is the basic idea of the deep learning. There are many types of the neural network. So different types of neural network, they have different principles. The first is the feed-forward neural network. Feed-forward. The word forward means just go to the front, forward. In feed-forward neural network, the data passes through the different input nodes till it reaches the output node. So let's say this is the input. So we can just go through until the output. There is no back propagation algorithm. Back propagation means you can return back to the first part. You can return back to the input. But the feed forward there will be no back propagation. There's another network, we call it radial basis neural network. The radial basis function considers the distance of a point with respect to the center. So the idea is like, this one, if you look at this. So it's somehow similar with the clustering. Okay? They want to find the center. They want to find the center and they check the distance. And the output of the network is a linear combination of the radial basis function of the input and the neural parameters. There's another kind of network, we call it coherent self-organizing neural network. So this is the example. So this is to use the coherent map. Yeah, this is just only for your information. They have the coherent map. And this is two input factors with the arbitrary dimension with the discrete map made of neurons. Yeah, this is just for your knowledge. I will not discuss in detail what is coherent. There's another type of the neural network, we call it RNN, recurrent neural network. It works on the principle of saving the output of a layer and feeding back to the input, help in predicting the outcome of the layer. So this RNN, if I have an input and then the network, the result of the network will be entered again. So it will learn and learn and learn until they have some good result. If there is no good result, maybe they will have some stopping criteria. After they finish with the stopping criteria, then they will make the output. There's another network, they call it convolutional neural network, or CNN. The CNN is similar with the feed-forward neural networks, where the neurons have weights and biases that are able to learn. But in the convolutional neural network, they call it convolution. Convolution. So they will make it, after we have the very big data, we will focus on the particular section of the data. So we will convolve it. They call it convoluted because we want to make it smaller, 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 and then we want to check based on the small data what is the result. So that's the type of the neural network, but for this class I will just focus only two. The first is the feed-forward network and the other is the back propagation. The feed-forward neural network means, this is the first and the simplest type of the artificial neural network. The multi-layer feed-forward network consists of input layer, one or more hidden layers, and an output layer. Each layer is made up of units. This is one unit. Or if it is the input, then it is the attribute. Attribute x1, x2, x3, xi. And then we have also the unit in hidden layer. This is the unit. And this is the unit, or sometimes we call it the neuron. And we have also the result. This is the unit. Y1, Y2 until YK. And the connection between these neurons, they call it weights. So we know if it is connected with another neuron, there will be weight. An n-dimensional input factor x is mapped into variable y by means of the scalar product and nonlinear function mapping. So we have the x, it will be mapped to the y by the scalar product. So this just multiplication. So like what you saw before in the example, we have like the simple linear unit is y equals to width multiplied by x plus the bias. So this is the simple example. So we want to map the x into y by means of the scalar product. This is the scalar. And the nonlinear function. So the nonlinear function is based on the weight. The inputs to unit are output from the previous layer. So if I have the input, I will go to the hidden layer and we call this is the output. And the output of this layer, it will be the input of this layer. And then after we have the result, then this output will be the input of this layer. So each layer will be calculated and it will go to the next. They are multiplied by the corresponding weights to form a weighted sum, which is added to the bias associated with the unit. So for every of this one, we will measure with the weight, and then we will sum of them. We will give the bias or like the errors, and there will be a nonlinear activation function. So there will be a nonlinear activation function before we go to the output. So that's the step of this multi-layer feed-forward network. So we call this is the feed-forward network. So this is the step. The input to the network correspond to the attributes measured for the training people. So let's say this is the attribute. This is the input. The input are fed simultaneously into the units making up the input layer. So we make this 1, 2, 3, and 4. They are then weighted. So there will be weight. There will be weight. There will be weight to the next layer, and fed simultaneously to a hidden layer. So this is the first hidden layer. The number of hidden layers is arbitrary. Arbitrary means, it can be any numbers. Although usually only one. So now we have one hidden layer. We can have two hidden layers. It depends. If you want to use only one hidden layer, that's okay. If you want to use two hidden layers, that will be fine. If you want to use 5 hidden layers, that is also fine. But when you have more hidden layers, of course, the calculation time is higher. If you have more hidden layers, usually we can have a better result. The weighted outputs of the last hidden layers are input to units making up the output layer, which emits the network prediction. So the input, the weighted output, so we calculate this one. The output will be the input of this one. And then after we calculate again here, after we have the value, it will be the input for this one. The network is feed-forward. So it means after we finish the first, we go to the second, we go to the next, and then we go to the last, and we do the classification. That's the meaning by feed-forward. None of the weights cycles back. So there will be no cycle back, no go back. From the statistical point of view, networks perform non-linear regression given enough hidden units and enough training samples. We can closely approximate any function. So this is a type of non-linear regression. Let's just see one example. Now I have this network and I have one hidden layer. So this is the hidden layer. If you still remember the simple example, we can make the formula. Now I have N1, N2. So I can make the formula like this one. N1 is the result of minus 2 multiplied by the x1, minus 2 is the weight, multiplied by the x1, plus minus 2 multiplied by the x2, minus 2 multiplied by the x2, plus the p1, p1 here. So it means I can say this is p1 is multiplied by 3 because the weight is 3. What about N2? N2 is here. We can see this one. 2 multiplied by x1, and then we have 2 multiplied by x2, and then we have the bias one. The bias one here will be multiplied by the weight, which is minus 1. Okay, I need to put this on -1 and this one should be 3. Okay. What about the y out? Y out is here. The y out is here is the result from the hidden layer. It means we have the 1 multiplied by n1 plus 1 multiplied by n2 plus the bias 2. The bias 2 with the weight, it is -1. So we will multiply with -1. Then we can make our formula. Let's say I know this input variable. So this is the x1 and this is the x2. Now let's do one by one. I know that the x1 is 0 and I know the x2 is 0. Then how can we make the result? If it is 0 and if it is 0, then I can check the n1. What is the n1? The n1 will be, we can just put the x1 is 0, 0 multiply -2 is 0, 0 multiply -2 is 0, plus 3. 3 is the bias. Then we have the result is 2. And then we can calculate the n2. n2 here is having with this formula. Again, we have 0 as the input in the x2 and 0 as the input in the x1 and x2. So 0 multiplied by 2 plus 0 multiplied by 2 plus the bias. The bias here is -1. Then the result is -1. What about the y out? I know that n1, the result of n1 is 3. And the result of n2 is -1. And we can just put in the formula 3 multiplied by 1 plus -1 multiplied by 1. And we put the bias. The bias is -1. So we have 1. Okay. Now let's say, I have, this is the true output. The true output is the actual. Okay. So this is the actual output from the data. If you still remember in the classification, we know the actual output. If it is the supervised learning, then we know the target data. And let's say this is the true output is 0. But the result from this network is 1. If in the case of this one, then we know there is a kind of gap. The true output is actually should be 0, but the result is 1. So you can also do it the same formula for the other input. We have x1 is 0 and we have the x2 is 1. We have, let's say the x1 is 1 and the x2 is 0. And we have the x1 is 1 and we have the x2 is 1. So you can calculate in the same way. You can calculate for the n1, we can calculate for the n2, and you can calculate also for the y out. And after you have this y out, we call this is the predicted output. And we want to check the prediction with the true output. So there are many ways. Let's say if I'm just giving you this example, if it is a regression, or it is, we want to predict the true output is like number. This is a number. So the loss function, let me just use this one. Y means the actual output, and y hat, it is the predicted output. And you can see from this formula, y minus y hat, which is 0 minus 1, and then we want to power by 2 or square, and then multiply with half. So the result will be half. Okay, 0 minus 1 power of 2 is 1. 1 divided by half, then is half. So the loss for this one is 0.1. The second data, it is 1 and the true output is 1. Okay, no problem. The next is the predicted output is 1 and the true output is 1. Then no problem. So the loss is 0, the loss is 0. But here, the predicted output is 1 and the true output is 2. Then we have the loss is 0.5. The easy way to understand from the all data about the errors, then we can just do summation. We can just sum, and the error equals to 1, because it is 0.5 plus 0 plus 0 plus 0.5, then it is 1. Based on that one, yeah, you can make on the Python. Let's say I have the input layer, and then I have the hidden layer 1, I have the hidden layer 2, and I have the output layer. So I can say this one is the activation function that I'm going to use. In the previous example, in this example, I do not use any activation function, but actually you need to have one activation function for every of this step. So before you get the result, you need to make like the activation function. This one also you need to make activation function. You need to make the with activation function. Just for a simple example, I do not use the activation function. Now, let's say I'm using the sigmoid activation function. So this activation function is using this formula. And we will start with the input, and this input is random. We have 3, 1, then it means we have 3 data in one column. And then we have, we have 3 data that is will be randomized, x1, x2, x3 for one row. And then we want to insert it into the h1, or this is the hidden layer. And we want to do the scalar. This is dot. Dot, it means the multiplication between the width and the x, width and x, and plus the bias. And then the h2, is another function based on this activation function. We want to have also the same, the dot, the product between the width 2 and the h1. h1 is from the hidden layer 1 plus the bias 2. And the output is a product from the width 3. This is the width 3. And we use the input from the hidden layer 2 plus the bias 2. Okay, so this is the way to do in Python if you want to code this feed-forward neural network with Python. And this activation function is using the sigma. Whenever we do this neural network, we need to understand the loss function. So the loss function means, yeah, you know, in the regression, we have the MSE, MAE, okay, or MS, or MSE. So that's one of the loss function. It is to quantify how good it's doing so that it can try to do better. The loss function or the error function is a function that tells us how good our neural network for a certain task. So we can use this neural network. Importantly, the choice loss function is directly related to the activation function used in the output layer for your neural network. So the activation function is also important to determine the loss function, and especially also the task, whether it is regression or it is binary classification or if it is multi-class classification. Just remember what is regression. Regression, it is when the target is numeric. What is binary classification? It is when the target is categorical with only two options, which is binary. What is multi-class classification? It is when the target is categorical and it has more than two options. So most machine learning algorithms use some sort of loss function in the process of optimization. And we want to find the best parameters, or we call this is the best way for your data. That's why this is a very high computational time, because we do not know what is the weight. So the neural network will calculate this on the weight, which weight will give you the best result with the smallest error. So this will be the loss function. If it is the regression loss, okay, so I already show you with this loss, the true output will be minus by the predicted output and will be squared and multiplied by the half. If it is the binary classification loss, we can use this loss function with log. So it means we want to see the true output with the respect of the predicted output. If it is a multi-class classification loss, then we need to do the summation, all of them for its output. Zero for all except true classes. So if we have only binary, we have only y log the predicted and 1 minus y log 1 minus y. Because we have multi classes, it is more than 2, then of course we need to check all the results. Okay, I think I will stop here. Any questions, comments? A lot of. Mhm. Yes, yeah, a lot of layers can also occur on within. There is no such rule. It's difficult to say how many layers, yeah, because it is based on the experiment, yeah, and also based on your computer, and it also based on your data. So we cannot say what is the best layer. That's the way usually, that's the problem in the deep learning, because we cannot define the architectures well. So any people can have their own architecture. Thank you for your question. Okay, so let's prepare the